In today's video, we'll learn how to solve for volume, perimeter, and area of geometric shape. Volume is the amount of three-dimensional space an object occupies. Volume is measured in cubic units, such as cubic centimeters or cubic meters. Volume also describes the amount of a substance that can be enclosed within a three-dimensional shape. Some common geometric shapes that have volume are listed in the chart to the right. Below we have two geometric shapes. If we are trying to find the volume of the two geometric shapes, we have a square pyramid on the left and a sphere on the right. If we focus on the square pyramid, to find the volume of a square pyramid, volume is equal to 1/3 times the base squared times its height. If we were to try to solve for volume, we see that the base of the pyramid is 12. So our base would be 12 squared, and our height is also 12. When we multiply this out, we get 1/3 times 144 times 12. If we were to punch this into our calculator, we would get a volume of 576. And there's no units listed, but if we were to say that our units were meters, our answer would be meters cubed. If we were to find the volume of a sphere, we'd use the equation where volume equals 4/3 times pi r cubed. So we see that our radius for our sphere is 8 meters. So we'll have 8 cubed. We would get 4/3 times pi times 512. If we plug this into our calculator, we would get 2,144 meters cubed as the volume of our sphere. Besides just finding volume of a geometric shape, we can find the perimeter of a geometric shape. Perimeter is the distance around a figure. If you're asked to find the perimeter of a circle, you'll often be asked to find the circumference. Down below we have a chart that lists how to find the perimeter of some common geometric shapes. If we were to look at the layout of the house in the figure to the right, and we were asked to find the perimeter of the dining room and the second bedroom, we could find it by adding up the lengths of each wall of each individual room. So if we start with the dining room, if we counted each wall, we see that one wall is 12 feet long, plus one wall is 2 feet long, plus then we have 5 walls that are both 6 feet long, plus a wall that's labeled 3 feet, and then our far wall on this side isn't labeled, but if we look at bedroom 1, we see that this wall is 11 feet. Therefore, this wall in the dining room must also be 11 feet. If we were to add these up, we could add these up and get a total perimeter of the dining room to be 58 feet. If we were then asked to find the perimeter of the second bedroom, we could locate the second bedroom in the figure and measure each wall of the bedroom. So if we start at the wall, most southward end of the bedroom, we see it's 8 feet long, and if we work around the bedroom in a clockwise direction, we'll see we have a 2-foot wall, another 2-foot wall, 5-foot wall, a 2-foot wall, and then our wall in the most northern end of the bedroom isn't labeled, but it's the same size as the wall in the southern part of the room, so that as well is 8 feet long. And then our far wall on the right isn't labeled, but if we look over into the living room, we'll see that the far wall in the living room is 9 feet. Therefore, the far wall in the bedroom must also be 9 feet. And if we were to add these up, we would get the perimeter of the bedroom being 36 feet. Lastly, we have area. Area is defined as the number of square units enclosed within the figure. If we were to measure our area, we measure area in square units, such as centimeters squared, or even meters squared. Now if we look to our chart to the right, we see we have a chart of some common geometric shapes and our equation to solve for their areas. Now that we understand the definition of an area, we have two polygons where Their area is unknown. If we were asked to solve for the area, how could we do so? Well, in our first figure to the left, we see we have a polygon with 3 rectangles. We see that the area of a rectangle is found by taking our length times our width. So we see our first rectangle has a length of 12 meters multiplied by its width of 5 meters. We see the area for that rectangle will be 60 meters squared. Now, for our second and middle rectangle, we see that the length of our rectangle is 6.5 meters plus this distance, which we see is 5 meters. So our length will be 6.5 meters plus 5 meters multiplied by its width. And since we see that this length of our polygon is 18 meters, and we can subtract 12 meters to find rectangle. So we can take 18 meters minus 12 meters, and then multiply it together, which will have an area of 69 meters squared. And then lastly, our last rectangle we see has a length of 11 meters and a width of 6 meters. And we multiply this together, we see that its area will be 66 meters squared. Now, find the overall area. We can sum up our 3 individual areas to find its total area. So we have 60 meters squared plus 69 meters squared plus 66 meters squared. And when we sum these up, we see that the total area of our polygon will be 195 meters squared. Now to our right, we have a second polygon, and if we were asked to solve for its area, we see we could calculate the area by summing up the areas of our 2 rectangles, our triangle, and our half circle. Well, if we start by solving for the area of our rectangle, we would have our length multiplied by our width. And if you notice that this triangle is directly similar to our second triangle, so we can find the area of one triangle and then multiply it by 2. And when we do so, we see that the area of our 2 rectangles will have an area of 384 centimeters squared if we were to assume that our measurements were measured in centimeters. And now we can find the area of our triangle, since we know that the area of a triangle is 1/2 its base, which we see is 16, multiplied by its height of 12. See the area of the triangle will be 96 centimeters squared. And lastly, we have to find the area of a half circle. Well, we know that the area of a circle can be found by taking pi r squared. And since it's only half of a circle, it will only be half its area, so we can divide it by 2. However, we're not given the radius of our circle, but we notice that the diameter of our circle is our hypotenuse of our triangle. If we were to use Pythagorean's theorem, we could solve for our hypotenuse. And we know that Pythagorean's theorem will be the height of our triangle, which is 12 squared, plus the base of our triangle, which is 16 squared. See that our hypotenuse will have a length of 20 centimeters, and that our hypotenuse is also the same as our diameter of our circle. And we know that our radius is 1/2 our diameter. So if we divide 20 by 2, we see that our radius is 10 centimeters. So now we can plug in our radius into our equation to solve for the area of our circle. So if we had pi multiplied by 10 centimeters squared divided by 2, we'd see that our half circle would have an area of 157 centimeters squared. Now in order to solve for the overall area of our polygon, we could sum up our areas. So if we summed up 384 centimeters squared plus 96 centimeters squared plus 157 centimeters squared, we see that the area of our figure will have an area of 637 centimeters squared.